All right, hey everyone. So today we're going to be talking about graphing different periods of sine and cosine. And your name is how do we graph different periods of the sine and cosine functions. Your homework is going to be in the OpenStax textbook. It's going to be page 520, numbers 11 to 14. And there's actually a note that I want to mention. So you're going to graph one full period and disregard the midline. That's the old homework, so disregard that. But yeah, so graph one full period and disregard the midline. Let me actually go to the textbook to show you what I mean by that. So in the textbook here, so you see for the following exercises, graph two full periods of each function. Instead of two full periods, I want you to graph one full period. So not two, but just one. And then here it says state the amplitude and period, which I want you to do, but you can forget about the midline because for the questions we're doing today for this homework, it's all just going to be the x-axis. And then after that, please state the max and min y values and their corresponding x values. So yeah, just the coordinates for the max and min on the graph. And then, yeah, you don't have to round for these, but yeah, it's 11, 12, 13, and 14, okay? But yeah, so again, graph one full period, state the amplitude and period, don't do the midline, and state the max and min coordinates, okay? All right, with that being said, let me get back to the lesson. All right, so for you to do now, it's graph y equals cosine x and cosine 2x on your graph calculator. Part B is how does the coefficient of x affect the graph? Is it stretched, shrunk horizontally or vertically? And how does this affect the period? Okay, so let me share my screen for the calculator. So we have to graph cosine x and cosine 2x. All right, so here is cosine 2x, but I just want to leave this blank to show you how I typed it in. So just cosine is here on the TI-84, and then x is right there, and then close the parentheses. And then yeah, cosine 2x is just the same, just enter a 2 right before the x. Okay, and then make sure your zoom, so it should be zoom trig, and then your mode is in radians. Okay, so to graph trig functions, make sure your calculator is in radian mode. But yeah, I'm going to do zoom trig, so option 7. And this graph that's coming up right now, it's cosine x. And then this graph is cosine 2x. Okay. So the questions were, this is part A, right? Just graph the functions. And then part B was, how does the coefficient of x affect the graph? So as you can see, it moves more quickly, right, with cosine 2x, right? But it's shrunk, right? So it's the area that it covers is halved. So like here, cosine x, one full period is here, right? So that's one full period for cosine x. And then for cosine 2x, one full period is here to here. So it's halved, okay? So it's shrunk horizontally by a factor of 1/2. So the area covered by one period is 1/2. Okay, but yeah, I'll get to the answer in just a sec. And then how does this affect the period was the last question. But yeah, the period is halved also, okay? So the coefficient of x affects the graph by shrinking it horizontally, and then the period is halved also. But yeah, let me show you the answer so you can see the actual wording. I'll zoom in just a bit. Okay, so how does the coefficient of x affect the graph? It shrinks the graph horizontally by a factor of 1/2, and the period is reduced by a factor of 1/2. Whereas cosine x would return to a value of 1 after a time of 2 pi, right? The period of cosine is normally 2 pi. Cosine 2x returns to that same point in half the time, namely pi. Another way to say that it's twice as fast, okay? Okay, so if you need these answers, please pause video here, or if you need to do now, right? So if you need any of this, please pause video here. And then also share the calculator, okay? All right, so you have those answers. Here's the calculator. Here's what it looks like. So again, this graph is cosine x, and the other graph here is cosine 2x. Okay. All right, but yeah, hopefully you have a calculator. If not, you can use Desmos. Yeah, to graph, cosine x or cosine 2x. Okay, but yeah, that's your graph. Okay. All right, let me get back to the lesson. All right, so for the rest of the lesson, let me just give you an overview. So it's the sine and cosine curves. Today we're going to talk about changes in period, right? So the period is modified, right? So either moves more quickly or slowly. I'll show you the notes in a sec, and then we have some examples, and then class for questions. Okay. All right, but yeah, with that said, let me get to the notes here. Okay, so here, sine and cosine curves. The sine and cosine curves, y equals a sine kx and y equals a cosine kx, assuming that k is positive, right, k is greater than 0, have amplitude absolute value of a, and period 2 pi divided by k. Okay. So you're just going to take that k value, and then 2 pi divided by that number is going to be your period, right? So for the do now, where it was cosine 2x, the period would be 2 pi divided by 2, or just pi. Okay. And the amplitude is always positive. It's always the absolute value of a. And then just a follow-up note to that is an appropriate interval on which to graph one complete period is 0 to 2 pi over k, inclusive of both. Okay. All right, if you need these, please pause video here. Otherwise, I'll keep moving. All right, so next is the examples. Okay. All right, we'll get to that diagram in just a sec, but yeah, find the amplitude and period of each function and sketch its graph. So first we have y equals 4 cosine 3x, and then y equals negative 2 sine half x. Okay, so find the amplitude, period, and then sketch the graph. All right. All right, here are the solutions. All right, for 4 cosine 3x, the amplitude is 4, right? Because absolute value of 4 is just 4. And then the period is 2 pi divided by 3. All right, so you see that there. And in order to sketch the graph, I actually like to organize it using a chart. So I remember when I was learning this back at Mystery High School, this is how my pre-calc teacher did it. And it stuck with me ever since. Find it to be very helpful. Hopefully you do too. Okay. So first row in this table is going to be the x coordinates for cosine x. So just the normal coordinates, right? It's from 0 to 2 pi, right? 0 pi over 2 pi, 3 pi over 2, and 2 pi. And then for the next row, we're going to divide by 3, right? Because, right, the period has been changed from 2 pi to 2 pi over 3. So everything is going to be divided by 3 accordingly. Okay, so this would be 2 pi to 2 pi over 3. This you divide by 3, so it would be 3 pi over 6 or pi over 2. Pi divided by 3 is pi over 3. And then pi over 2 divided by 3 is pi over 6. And 0 divided by 3 is 0. Okay, so these are the x coordinates that we're going to plot here. And then the y coordinates are the normal y coordinates for cosine. And then in the next row, we adjust for the change in amplitude. Okay, so normally cosine is 1, 0, negative 1, 0, 1, right, at these coordinates, right? So cosine 0 is 1, cosine pi is negative 1, right? Cosine 3 pi over 2 is 0, cosine pi over 2 is 0, right? So normal coordinates for y. In the next row, we multiply by 4 because, yeah, the amplitude is now 4. So just multiply everything by 4. So this is 4 now, this is 0, this is negative 4, this is 0, this is 4. Okay. And these two rows are what we're going to plot. So these are the x coordinates that we're going to plot, and these are the y coordinates we're going to plot. Okay. All right, if you need to copy this down, please pause it right here. Otherwise, I'll get to the graph. All right. Yeah, so here's your graph. It's from the old textbook. So our first set of coordinates are 0 to 4. Sorry, not 0 to 4, 0, comma 4. So 0, comma 4 is right here. That's our first point. And then next we have pi over 6, comma 0, which is right there. Pi over 6, 0 is right there. Then pi over 3, negative 4, which is here. And then that's followed by pi over 2, 0, and 2 pi over 3 over 4. 2 pi over 3, comma 4, sorry. Pi over 2, 0 is here, and then 2 pi over 3, 4 is here. Okay, so note that the textbook shows more than one full cycle, but yeah, for the sake of our table and for the homework, you only have to graph one full period. All right, so you technically only have to draw this part, okay, like that. All right, but yeah, that's your graph for part A, and then next I'll be moving on to part B. But if you need this, please pause the video here. All right, next is negative 2 sine half x. So the amplitude is 2, so at positive 2, right? because absolute value of negative 2 is 2. And then the period is 2 pi divided by 1/2, so that'll end up being 4 pi. Okay. All right, same chart as the previous question. So 0 to 2 pi for the x coordinates, and then we adjust, right? So for the new graph, right, everything is divided by 1/2, or another way to say that is multiplied by 2. So multiply all these by 2, you get 4 pi, then 3 pi, 2 pi, pi, and 0. Okay. For the y coordinates, it's going to be, right, for sine, normally it's 0, 1, 0, negative 1, 0. And then if you multiply it by negative 2, right? So yeah, here you have to be careful. So even though the amplitude is 2, everything is being multiplied by negative 2, right? So multiply everything by negative 2, we get 0 here, positive 2, because negative 1 times negative 2 is positive 2, then 0, negative 2, and 0. Okay, and these are the coordinates that you're going to plot. Okay, 0 to 4 pi, and then 0, negative 2, 0, 2, 0. All right, but yeah, that's, so 0, 0 is here, then pi negative 2, then 2 pi 0, then 3 pi positive 2, then 4 pi 0. Okay, that would be right there. All right, if you need this solution, please pause the video here. Otherwise, I'll keep moving to the classwork questions, which I believe are next. All right, yeah, classwork questions. Okay, so find the amplitude and period of each function and sketch its graph. Okay, so basically the same thing as the last two examples we did, just different functions. Okay, so we have 2 cosine 3x here. The period is going to be 2 pi divided by 3. Amplitude is 2. Okay, so here I made my chart, 0 to 2 pi. And then here I divide everything by 2. Okay, so 2 pi divided by 3, 3 pi over 6, or pi over 2 if you reduce it. Then pi over 3, then pi over 6, 0. And then for the y coordinates, it's 1, 0, negative 1, 0, 1, normally for cosine. But now we're multiplying by 2. Okay, so it'll be 2, 0, negative 2, 0, 2. Okay, and those are the coordinates we'll plot. So 0, 2 is our first point, which you see here, 0, 2. Then pi over 6, 0. So pi over 6, 0. That's right here. And then we have pi over 3, negative 2. So pi over 3, negative 2, that's over here. And then pi over 2, 0, which is right here. And then lastly, we have 2 pi over 3, comma 2, which is right there. Okay. All right, so if you need this chart here, please pause the video here. And then if you need this graph, let me zoom out just a bit. If you need this graph, please pause the video here. All right, so that's your first classwork question. Next we have negative 5 sine 1/3 x equals y. So the period is going to be 2 pi divided by 1/3, or 2 pi times 3, right? So that'd be 6 pi. And then the absolute value of negative 5 is 5. So the amplitude is 5. Okay. All right, so same first row, 0 to 2 pi. And then here in this row, we're going to multiply each of these values by 3, right? Because we divide the period by 1/3, or another way to say that is multiplied by 3. Okay. So we're going to get 6 pi here. Then this times 3 is 9 pi over 2, or in decimal form, that's 4.5 pi. This times 3 is 3 pi. Then this times 3 is 3 pi over 2. Then 0 times 3 is 0. Okay, so these are the x coordinates we're going to plot. And then for the y coordinates, the next row is the same, 0, 1, 0, negative 1, 0 for sine. And then here we're going to multiply by negative 5. Okay, so it'll be 0, negative 5, 0, positive 5, and 0. Okay. All right. But yeah, the first coordinate we plot is 0, 0. Then we have 3 pi over 2, negative 5 here. Then 3 pi 0. Then 9 pi over 2, or 4.5 pi, 5. And lastly, 6 pi 0. Okay. And your sine graph is going to look like this, right? Notice that's like reflected over the x-axis, right? Because of the negative 5, right? So that'll reflect. All right, if you need this question, please pause the video here. Otherwise, I'll move on to question 3. All right, question 3. Here it's y equals 2 sine pi of x. So period is 2 pi divided by pi here. So the coefficient k is pi, right? So 2 pi divided by pi is just 2. And the absolute value, the amplitude is just 2, right? Okay, so first row, same as always, 2 pi. And then for this row, we divide by pi, okay? So we get 2 here, then 1.5, right? 3 pi over 2 divided by pi, you just get rid of the pi. You get 3 over 2, or just 1.5 in decimal form. Pi divided by pi is 1. Pi over 2 divided by pi is 1/2. 0 divided by pi is 0. Okay. All right, y coordinates are the same here in the third row, 0, 1, 0, -1, 0. And then from here, we multiply by 2. So 0, 2, 0, -2, and 0. Okay, so these are the coordinates we plot. Not those, not those. These, this row, and this row. Okay, so 0, 0 is our first point. Then we have 0.52, which is here. And then we have 1, 0. Okay, so note that the scaling is, so this is from Desmos, but you can even change the scaling to like the numbers that you write. They could even be 0, 0.5, 1, 1.52. That's fine. All right, but note that here is like pi over 4, so that's literally like 3.14 divided by 4. Okay, so but 1 will be right there, right? 1, 0. And then we have 1.5, -2, which is here. And then we have 2, 0, which is here. Okay. Yeah, but that'll be your graph. So yeah, you should be noticing that these look the same as any other sine or cosine graph, except, the only thing that changes here are the labels for the x or the y-axis. Okay. But yeah, everything, the shape is the same. Okay. Now in a later lesson, we'll see a phase shift, which means it shifts horizontally. So in that case, it will look different, but in this lesson, these graphs look the same. Okay. All right. If you need this solution, please pause the video here. Otherwise, I'll move on to our last question. All right. Fourth question was a word problem. So as a wave passes by an offshore piling, the height of the water is modeled by the function h of t equals 3 cosine pi over 10t, where h of t is the height in feet above mean sea level at time t seconds. Okay, so the dependent variable is height in feet above sea level, mean sea level, and then time t, the independent variable, is in seconds. All right, part A, find the period of the wave. So yeah, just 2 pi divided by that coefficient k. So 2 pi divided by pi over 10. So that'll be 2 pi times 10 over pi, right? Take the reciprocal. So pi divides out, you're gonna get 2 times 10, which is just 20 seconds. Okay, so that's part A. Part B, find the wave height, that is the vertical distance between the trough and the crest of the wave. So trough and crest, these are words that we saw in yesterday's lesson, but actually let me show you a diagram. So the distance between the trough and the crest is what we're trying to find. And this is the diagram from before. So the trough is just basically sorry for the bell. Okay, pardon for the interruption. The trough is the minimum value here, and then the crest is the highest value. Okay, so the crest is like the max, the trough is the minimum value. Okay, but yeah, we need to find the distance between this and that, the vertical distance here. Okay, and that'll be, okay, so the distance is twice the amplitude, right? So it'll be, the amplitude here is 3, right? Absolute value of 3 is just 3, and then 2 times 3 is 6 feet. Okay, so yeah, again, just trying that. So here's the crest, here's the trough. If the amplitude is 3 here, right? The amplitude is 3, then we just have to double that to find the distance between this and that. Okay, so it'll be 2 times 3, which is just 6 feet. Okay, all right, but yeah, that's all for today. And if you need the solution, please pause video here. Otherwise, yeah, just submit your homework as always, and I'll see you all soon in the Zoom session. Have a great rest of the day and take care.